In this video, we're going to be looking at how to do calculations with mechanical energy. So what is mechanical energy? Mechanical energy is simply the total energy of the system. In our calculations, we're going to assume it's an isolated system. Isolated systems have no energy losses. Now, this is not really the case in real life because we often get energy losses from the system due to heat and sound. But we're going to assume that there is no energy losses from heat or sound. So for our purposes, mechanical energy will simply equal the potential energy plus the kinetic energy of the system. So with any physics calculation, we're going to apply standard problem-solving techniques. We're going to underline the key points, we'll make some lists, we'll write down some formula, we'll substitute the values, remember the units, and remember if it's a vector quantity, we have to give a direction. Let's look at our first example. Kate throws a ball of mass 150 grams. So immediately you should see there is a problem here. 150 grams needs to be converted into kilograms. And it's thrown directly or vertically up into the air. The ball leaves a hand with an initial velocity of 6 meters per second. And so that's 6 meters per second up. And it says calculate how high the ball reaches. And remember, gravity is 9.8 meters per second down. Now, because these problems can be a little bit difficult in seeing what is going on, I always like to draw a picture. And here's my picture of Kate. And here's the ball she's holding. And she's going to throw it vertically up into the air. And of course, it'll come back down again. Now, at this point here, it has the maximum kinetic energy in the system. And at this point here, it has maximum potential energy. Now, remember, mechanical energy is equal to potential energy plus kinetic energy. So at the bottom, potential energy is pretty much zero. So the mechanical energy will be equal to the kinetic energy. So let's calculate the kinetic energy. Kinetic energy equals 1/2 mv squared. So it is 1/2 times the mass, which is 0.15, times the velocity, which is 6 squared. So this comes out to 2.7 joules. We now need to find the maximum potential energy at the top. So at the top, we know that mechanical energy is equal to kinetic energy plus potential energy. So we know that mechanical energy is 2.7 joules, which we calculated previously. We don't know the potential energy, but we know at the top, the ball stops a moment in time, so it has 0 energy. So the potential energy is equal to 2.7 joules. We can now calculate the height that the ball reaches. So the potential energy was 2.7, the mass was 0.15, we know gravity is 9.8, and we know we don't know the height. So 2.7 must equal 1.47 times the height. So the height must equal 2.7 divided by 1.47, which is equal to 1.84 meters. Now let's look at another example. Gemma drops a rock, 200 grams, which is 0.2 of a kilogram, down a well which has a depth of 23 metres. And we want to do a few different steps here. So let's just draw a picture to start with. So here is our picture of Gemma, and she's standing on the surface here, and she's going to drop a rock that goes all the way to the bottom. Now at the top here it has maximum potential energy, and at the bottom here, just before it hits, it has maximum kinetic energy. So let's work out what's happening. So at the top, our mechanical energy is equal to potential energy plus the kinetic energy. But at the top, the mechanical energy must be equal to just the kinetic energy. Potential energy, sorry, because the kinetic energy is equal to 0. So let's calculate the energy at the top. So potential energy must equal mass times gravity times height. Mass is 0.2, gravity is 9.8, and the height of this is 23 metres. And this comes out to 45.08 joules. So 45.08 joules is our total energy of the system. Now let's do part A. Part A, we want to know the potential energy at 15 metres. So we're going to calculate it. Potential energy equals mass times gravity times height. The mass was 0.2, gravity was 9.8, and the height was 15. So in this case, it is equal to 29.4 joules. Now we know that the mechanical energy equals potential energy plus the kinetic energy. We know the total energy of the system is 45.08 joules. We know at 15 metres it is 29.4 joules of potential energy, so we can find the kinetic energy. And the kinetic energy equals 45.08 minus 29.4, which comes out to 15.68 joules. From there we can solve for part B, how fast it's travelling at that point, because kinetic energy equals a half mv squared. 15.68 equals a half times 0.2 v squared. So v squared must equal 156.8. So v must equal the square root of 156.8, which equals 12.52 meters per second down. Now let's solve part C. At part C, it says calculate the velocity just before it hits the bottom. So just before it hits the bottom, all the mechanical energy has been converted into kinetic energy because it has no potential energy left. So 45.08 joules is equal to kinetic energy plus 0. So now that we know that the kinetic energy is 45.08 joules, we can calculate its velocity. So kinetic energy is a half mv squared. 45.08 equals a half times 0.2, which is v squared, so now we need to solve. 45.08 equals 0.1 v squared. V squared must equal 45.08 divided by 0.1, which is 450.8. So therefore velocity must equal the square root of 450.8, which equals 21.23 meters per second down. You need to try some of these yourself, so go to the OneNote Physics Unit 2 Energy, and the worksheet Mechanical Energy has lots of examples for you to practice.